Hi everyone, my name is Darshan Prasad and this is my final project presentation for the course Principles of Cloud Computing, course number 605.635, taught at Johns Hopkins University. So for this project, we were asked to explore a cloud platform provider or service that applied to a domain of interest and to produce a video explaining what we learned. So for my project, I chose to explore AWS's offerings for running machine learning tasks and workloads, which is an area that I am very interested in. So machine learning continues to increase in popularity. However, training machine learning models often requires access to expensive compute resources, and some deep learning models even require GPU acceleration in order to be trained in a practical amount of time. So the question I had was whether we could use cloud computing services to lower the barrier to machine learning model training and to make training these models more cost effective. So Amazon offers many services that can be used for machine learning. The one we'll focus on in this video is Amazon ECS, or the Elastic Container Service. And ECS will coordinate the launch and resource allocation of Docker containers for you. It will auto-scale instances to elastically meet any increase or decrease in demand. And ECS can be used for long-running processes like application servers, but also for tasks like machine learning training jobs. So for those of you unfamiliar with Docker, Docker is a technology that containerizes applications, processes, and other software into a virtual format. And this format often includes or contains the full runtime environment for the software to run, including the operating system, the package dependencies, the application frameworks, and any data volumes. So Docker containers help make software highly portable, and they can be deployed in any environment where a Docker engine is installed. And Docker is cross-platform and runs on Mac, Linux, and Windows. So the way Docker containers work is they instantiate something called a Docker image. And Docker images are runtime specifications for the virtual environment that you're creating. So Docker images can be written interactively on the command line using the Docker CLI, or they can be written in a Docker file. And the nice part about using a Docker file is you can use it to rebuild your Docker image at any time. So you can commit Docker images to cloud repositories such as Artifactory or Amazon ECR, where the images can be stored and versioned. And often, if a piece of software is containerized in a Docker image, the Docker image will take on the same version number as the software's release. So, here's some examples like Nginx, Tomcat, Python, MySQL, Linux, etc. They all have Docker images available for free. So one other tool that I want to mention that we'll use is the Jupyter Notebook. And Jupyter Notebooks are used for training machine learning models and for experimentation. And they can be thought of as kind of a combination of a wiki and a Python terminal tool. Notebooks help keep machine learning results reproducible, and they're used extensively by machine learning and data science practitioners. So let's give Amazon ECS a try with Docker. So our proposed solution starts by using Docker to containerize a machine learning environment, and then we'll then deploy this Docker container to Amazon ECS for orchestration. We'll then train our model and test it using the Jupyter Notebook that we have for the model. So what we'll build is we'll be training and running the MNIST classifier. So MNIST is a database containing images of handwritten digits, and the classifier is really a machine learning model that takes as input a handwritten digit image, and it can then accurately predict the digit in the image. So MNIST is a good candidate for a demo since it doesn't take too long to train, and we'll use the MixNet deep learning framework for running the MNIST classifier. So MixNet is maintained by Apache. It's a machine learning framework, a deep learning framework that many data science and machine learning practitioners use for training models. Okay, so first off, credits go to this video, which helped me get started with ECS. So over in the ECS tab, the first thing I want to point out is actually this repositories link. So Amazon ECR allows you to create repositories for your Docker images, and it's fairly simple. You click on Create Repository, and you get this URL for your Docker images, and you can call your repository anything. I've already created one called Cloud Computing Project, so we'll go ahead and use this one. Now, once you have a repository, you can click on this button that says View Push Commands, and this will list how to authenticate to your Docker repository, and then how to build your Docker image, tag it, and push it to the cloud repository. So let's go ahead and do that. But first, what I want to do is actually show everybody what my Docker file contains. So as I mentioned, we'll use the MixNet framework for training our machine learning model. And this from directive in the Docker file actually says that we're going to use the MixNet Python image as a base image for our own custom image. So this is an image that's already been built, and it's been pushed to the public Docker Hub, and we can go ahead and use it in order to import the Docker image and the runtime environment that's already been constructed for MixNet. So this includes all of the package dependencies and all of the environment variables, all the things that are needed for MixNet that are already present in this image. The things that we want to do are, we want to install a couple Python packages, namely requests and Jupyter. So requests is a specific Python module used for HTTP requests, and then Jupyter, as mentioned before, installs the Jupyter Notebook platform. We're just going to create a directory for our project inside the Docker container, and that's going to go under OPT MNIST. Workdir will just change the location of our current working directory to that newly created directory for our MNIST project. I'm going to copy a file from the host machine here, which is my laptop, and I'm going to copy it into the current working directory. So this is the MNIST Python notebook that's provided by sort of the MixNet documentation as a sample. And so inside this notebook is sort of the code to train the model and to test the classifier as well. Here we'll expose the port 8888, and that will allow us to access our Jupyter Notebook on the EC2 instance that'll actually be running this Docker container. Okay, so now that we've covered the Docker image, the Docker file, let's go ahead and run this command provided by the Amazon ECR registry in order to authenticate to the Docker repository that we just created. And this command does use the AWS CLI, so that is a dependency for this project. So it looks like the login succeeded. So the next command is to build the Docker image, and that Docker image again is specified through the Docker file that we were just reviewing in the terminal. I've actually already constructed the Docker image for this project, but I'll go ahead and rerun this command just so that the syntax is familiar. And it builds much quicker now because all the layers were already previously built and cached. So let's go ahead and tag the Docker image and then tag it to the repository that we created. So I'll go ahead and say Docker tag. I've named it something different than the default, so I'll make that change. And then we'll push it up to the repository now that it's been tagged. And this could take a while depending on the size of the image and the internet connection speed, so I'll go ahead and fast forward to when this push is complete. Okay, so our Docker image has been pushed up to our cloud repository. So the next step is to head over to task definitions. So task definitions will help us specify how many resources are needed for our particular Docker container task, and it'll allow us to provide some additional metadata around what our machine learning task is going to be. So we'll click Create New Task Definition. We'll use EC2 for this project. The task definition name can be something simple like launch MNIST notebook, and we're allowed to specify a lot of things like task size, how much memory and CPU we want. We'll just go ahead and accept the defaults for all those. The container name, we can just call MNIST classifier. The image, I'm going to go ahead and paste this URI in for the location of the Docker image that we just pushed to. The memory, we'll just say a soft limit of, we'll say a soft limit of let's say like 5,000 megabytes, because I know machine learning workflows are pretty memory intensive. So the port mappings we also have to add because we do have the Jupyter notebooks running on port 8888 that was specified in the Docker file. So we'll go ahead and map that to the same host port, and it's TCP protocol, so we'll keep that the same. We won't add any advanced container configuration for now. We'll go ahead and say add this task definition, and there we go. So we'll say create. So that's been created successfully. All right, now that our task definition has been saved successfully, we'll go to the clusters tab, and we'll create a new cluster to support running our Docker container. And we'll use EC2 with Linux. We'll say an on-demand instance, and the cluster name can just be called MNIST cluster. Let's use something like a T2 large instance, which will have, I think, plenty of memory for us to use. And we'll just say one instance for now. And we'll say this key pair that we have saved so we can SSH into our EC2 instance. The VPC, we can just use our default VPC that was created from before, and we can add each of the subnets that belong to the VPC. And we'll just use this launch wizard security group that we had created from before. And we have this ECS instance role, IAM role that we can use to access EC2 instances with ECS. Okay, and it looks like the cluster is successfully created. Okay, so now that our cluster is up and running, the next step is to create a new service for our Jupyter Notebook task, which will allow us to access the Jupyter Notebook on the EC2 instance and then kick off the training for our machine learning model. So we'll say the task is the launch MNIST notebook, and the cluster is this MNIST cluster. Service will just be called the Jupyter Notebook. Service type. And we'll just call this, the daemon, which is fine. And we'll accept the defaults for deployment and say next step. We don't need service discovery, and we'll skip load balancing as well since we'll be the only people using this. I'll say next step and say create service. So we'll go ahead and click view our service. And we'll see now that under tasks, there is a pending task for launching our Jupyter Notebook. All right, so that task has now changed state to running. So let's go ahead and click on it, take a look. And we do see that it's assigned as part of the MNIST cluster. And this task does use a Docker container. So the Docker container is the MNIST classifier. And as we had defined in the Docker file, we are exposing port 8888 up to the host. So this is our EC2 instance URL, it looks like, and the service that we just created is running on that 8888 port. So if we open this, we should see the Jupyter Notebook launch, and we do. So the Jupyter Notebook actually, for security reasons, requires a authentication token to be entered on public IP addresses. So I went ahead and logged into the EC2 instance to save some time and collected the token. So it's available here. So we'll just go ahead and copy that and paste it and say login. And now we see that we have the MNIST notebook that we had actually copied into the Docker image when we did the Docker file definition and the Docker build command. So we'll click on this notebook. And here we go. So this is the information for MNIST, and now we can just go ahead and work our way through this notebook in order to train the classifier. So we can say run cells here, and this will actually perform the first step, which is loading data. Then we can define batch size and sort of the training iterations. We can get ready for training. And if I just click now, run all, this should begin training the model as well as testing it. So this will take a few minutes. So I'll fast forward to when the model has been trained in order to get back to the results. All right, and it looks like the training has completed, and we've also been able to do an evaluation and a test. And as you can see, the classifier, um, as it trains over each epoch, it increases in accuracy. So it climbs actually rather rapidly, and then as it gets to the later epochs, it gets quite high, and then the validation accuracy is around 98%. And then in the prediction, we use some of the test data provided by the MNIST dataset, and we can see that the evaluation metric is that the accuracy is, again, 98%. So using MixNet, we're able to load the MNIST training code as well as the training data, and we have this sample Jupyter Notebook also provided by MNIST, which we're able to run on our EC2 instance on the container service, and we can run this as a long-running Docker task, especially for machine learning jobs that might take even longer than MNIST. Particularly for deep neural networks, they can take quite a bit of time to run. So Amazon ECS provides us with this Docker container orchestration mechanism, and within those Docker containers, we can spin up things like Jupyter Notebooks in order to train machine learning models. So in conclusion, we learned how to containerize our application environment using Docker. We used a Jupyter Notebook for MNIST provided by the MixNet sample documentation in order to train the MNIST classifier and also test the model once it was produced. We also learned how to launch a Docker container on an Amazon ECS cluster. And of course, all of the tools that we used can be used for many different types of workloads, but we were able to apply them to our specific area of interest, which is machine learning. So lastly, I just wanted to provide some references. So the AWS tutorial series is very helpful in exploring various AWS topics. For this video, I referenced this tutorial called Getting Started with ECS. The MixNet Docker image page, this contains information about the MixNet Docker image that we used as our base image when we ran our Docker container in our ECS cluster. MixNet also provided the sample MNIST notebook, which is available on the product documentation for MixNet, and so we downloaded the MNIST notebook from there and uploaded it to our EC2 instance via our Docker container. We actually constructed our Docker image to contain the MNIST notebook. And then lastly, this is the homepage for Amazon ECS, which has lots of other information on how you can configure and launch ECS clusters for various types of workloads. Finally, I just want to thank Professor Shyamsundar and Professor Joshi for a great semester in Principles of Cloud Computing. I definitely learned a lot, and it was a really great course, I think, with lots of opportunity to apply learnings from the semester. So thanks again, and really appreciate your help.